Hello everyone, welcome to my video presentation. Today we are going to talk about a cool instrument that plays a very important role in the world of meteorology, the automatic rain gauge. Some of you might be wondering, what is a rain gauge? Well, simply put, it's a device used to measure rainfall automatically. A tipping bucket rain gauge is a type of automatic rain gauge that measures rainfall by counting the number of times a small divide the bucket tips over as it fills with rainwater. Each tip represents a specific amount of rainfall, allowing for accurate and automated measurement without manual intervention.
So next, weather observation according to STMKG and WMO is the activity of recording atmospheric elements such as temperature, air pressure, humidity, rainfall, wind directions and speed, as well as cloud conditions, conducted regularly in accordance with established standards. The purpose is to support weather forecasting, climate studies, and disaster mitigation efforts. STMKG refers to international standards set by WMO regarding the use of instruments, observation methods, equipment placement, and observation timing. Weather observations are generally conducted every 3 hours UTC at synoptic stations or several times a day at climatological stations. Data is collected using instruments such as thermometers, barometers, anemometers, and rain gauge, then encoded and transmitted through the Global Telecommunication System or GTS. This standardization ensures that weather data from Indonesia can be integrated with data from other countries for meteorological analysis and early warning system at the global level.
The next topic we'll cover is the main components of a tipping bucket rain gauge. The main components of a tipping bucket rain gauge consist of 4 parts. First, the collection funnel gathers rainwater and directs it into the buckets. Second, the tipping bucket itself comprises 2 small buckets balanced on a pivot. These buckets alternately collect water and tip over when full. Third, a magnetic sensor detects this tipping motion and converts it into a digital signal. Finally, a data logger stores the number of tips, which are then calculated to determine the total rainfall.
Next, I will explain how to install an automatic rain gauge tipping bucket type based on BMKG and World Meteorological Organization standards. First, choosing the location. Place the tool in open area, far from trees, buildings, or tall poles. The distance from any object should be at least twice the object's height. Avoid low area that can float or collect water. Second, preparing the base. Use a concrete base or a strong metal pole. Make sure that the base is flat and level using a water pass. The funnel should be 30 to 50 cm above the ground. Third, installing the tool. Put the tool on the base and tighten it firmly. Make sure the funnel is straight and not tilted. Check the tipping bucket to make sure it can move freely. Fourth, connecting the sensor and power. Connect the sensor to the data logger. Also connect the solar panel and battery if using one. Make sure all cables are safe from water and weatherproof. Fifth, testing and protection. After installing, test the tool by pouring water into the funnel using a measuring cup. Make sure the bucket tips correctly and the data is recorded. Then install a simple fence around the tool to protect it from animals or people. Leave about 1.05 to 2 meters of space so rain can fall freely. With testing and protection done, the rain gauge is ready to use. So that was the installation process for the tipping bucket automatic rain gauge.
Work principle: automatic rainfall measuring instrument. This instrument consists of 2 buckets placed in balance. When it rains, the bucket will fill with water, and when full, the bucket will tilt down so that the number at the end of the bucket is read by the red switch sensor. As transducer, the end of the bucket is measured and converted into rainfall units. This rainfall value will be displayed on the AWSDG and AWS-estimate. The formula rainfall by millimeter is number of seesaw cross volume of each seesaw by 0.2 millimeter.
Yup, that's all our discussion about automatic rain jets. Hopefully, this explanation can add insight and make us better understand how these instruments works. Now, we know that a tool as small as the automatic rain jets has a big role in observing the weather. Thank you for listening to Dan, and don't forget, have a bright day.